Good morning, good afternoon, good evening, wherever you might be, and welcome to my post on the climate, peak oil, and peak phosphate. I am not a climate scientist by training or a geologist, but I have had 20 years of experience with physics, experimental physics, and have a lot of respect for the scientific method, and I understand very well how difficult it is to test hypotheses about the climate. So I hope you enjoy my take on this issue as a sort of outsider. I'm not a corporate person or a climate person. I am just a person with a physics background who wanted to understand these issues on a fundamental level. So, what I understand is that oil powers the machines we use to create food, and phosphate improves our ability to extract food from the earth. So, when economists estimate that the global debt to the future is over $50 trillion, this number is only meaningful if given in terms of per capita oil and phosphate, a number that you can't find anywhere, I'm sure. As a thermodynamics problem, the world has a finite amount of energy which is easy to extract, and there is a certain amount of energy required to extract that energy. What is left over can be used to have fun and prepare for our future energy extraction needs. But when we neglect the investments required to make energy easy to extract in the future, we build up a debt to the future. The $50 trillion debt that different countries have built up to each other might be proportional in some way to our energy debt. You could make a rough estimate by making a weighted average of every country in the world's debt to GDP ratio. This gives a measure of how much we are producing versus how much we are consuming. It tells a country roughly how many extra years they would have to work in order to break even relative to some other country. For example, a 100% debt to GDP ratio tells you that you need to work twice as much next year in order to pay off your debts next year. If peak oil is due in the next decade, and we can replace gas-driven cars with electric cars, we are fine. So peak oil, if you don't know that term, it's the peak of easy energy extraction. After that, it becomes more difficult to extract that energy. If peak coal happens 10 years after that, and we have built enough alternative power plants, then we are fine. The trouble arises if we don't invest in these areas enough in advance of the peak of easy energy extraction. Coupled with the pressures of population increase and industrialization of developing nations, this can lead to a sharp collapse, as we have to devote more and more of our energy to energy extraction, not leaving enough to develop technologies which can make energy easy to extract again. A collapse can happen when demand spikes just as supply drops. And at the moment, energy extraction is extremely easy. It's hard to keep prices high enough even. People start wars to increase the prices. And people have been skeptical of these claims of the dangers of peak oil ever since they were brought out many decades ago, because we have been continually underestimating how good we would get at extracting energy. We're a bit better at it than anticipated, and that means that the curves that people have projected into the future have been wrong. That doesn't mean that the entire concept is wrong. It just means that we're not particularly good at estimating these things. A similar problem arises in the realm of phosphate extraction. We can turn our biodegradable waste into phosphate, or we can mine dwindling supplies of phosphate rock from the Western Sahara. Presently, it is more economical to mine the rock than to process our waste. At present rates of consumption, the rock supply may give out as soon as 2040. In short, we are living in a time of rapid growth, but we are doing so by burning up limited resources, and I suspect that this energy debt to the future is a much bigger concern than any impact of carbon dioxide on the climate. Nevertheless, both issues place political incentives in the same direction. So perhaps there is little incentive to let the hoi polloi in on the joke. For most of my life, I blindly accepted carbon dioxide-mediated global warming hypotheses and research. But after having worked in large government-funded scientific institutes for most of my career, I understand how much scientific research can be motivated by the need to get funding. The need for funding causes researchers to put a political spin on their work. They want to be heroes, too. This leads to exaggerated claims about what is known with absolute certainty. If the way to get more funding or to feel like more of a hero is to tell everyone that there is an impending crisis, that is what researchers will do. After reading predictions of a little ice age between 2030 and 2050 due to solar inactivity, I started to wonder about what has typically driven long-term climate changes throughout Earth's history. Was it asteroids or volcanoes or the sun or the heating of the oceans? There were changes of more than 3 degrees throughout human history. In fact, olive trees grew in Germany back in the Roman times along the Rhine, and there were barley farms in Greenland during Viking times. Human civilization tended to do better during warm times than in cold times, and we are not presently living during an extremely warm time, historically speaking. Our memories about weather are rather short-term. I mean, mine only goes back to 2011 when we had a lot of snow, and then in recent years we've had practically no snow. What we have measured in modern times is a 1 degree increase in sea surface temperature since 1850, which, when you look closely at the data, is more likely an 0.5 degree increase due to biased data interpretation. I personally investigated this by reading the primary sources, not just the science article, the glossy magazine. I read the journal articles, and I looked at their data analysis methods and the sorts of error estimates they made. And coming from another field within science, I thought they were hedging on the side of overestimating an effect rather than underestimating it. And so, for example, after a close reading, I found that in the widely discussed 2015 Science magazine paper, Possible Artifacts of Data Biases in the Recent Global Surface Warming Hiatus, NOAA has averaged together several weighted and biased data sets to produce a warming trend that was not present in the individual data sets. The newer, more accurate buoy data was adjusted 0.12 to 0.18 degrees upwards to match the average temperature of the more abundant, less accurate, systematically too warm ship engine intake data. A reasonable researcher would have moved the too warm data down to match the better buoy data, instead of moving good data upwards to match bad data. This choice makes the post-1990s data look artificially warmer. On the other side of the trend, pre-1940s data was adjusted to make it look colder. The older data had a systematic error of between 0.1 and 0.8 degrees downwards. Recall that they're claiming the data shows a 1 degree increase. And if we have an error of between 0.1 and 0.8 degrees, I mean, really, what are they doing? So there's a systematic error due to evaporative cooling of the water collected in their measurement buckets. But the researchers from NOAA chose an error estimate of 0.2 degrees at the very lowest end of the possible error range, making the pre-1940s data look artificially colder. Thus, when they average and splice the data from 1850 up to the present together, they get a 1 degree warming trend that is largely an artifact of the 0.12 to 0.18 degree upward adjustment in the newer data and the undercorrected 0.1 to 0.8 degree systematic error downwards in older measurements. Without this manipulation, the warming trend since 1850 would be less than half of what NOAA claimed. So if you click on the link, you would come to a blog post I've written about this, and I have links to those papers and some of the charts from those papers. So 2 of those articles in the blog post are both cited to support the NOAA claims in the glossy Science magazine article, and I see them as representative of the NOAA methods. I think they take liberties with the data that would not be accepted in other fields. The 0.5 degree step-like discontinuity in the raw data at 1940 is troublesome because it marked a transition from older ships and data collection methods to newer ones, and they use this step to make their case. And the step is completely ambiguous, and you can't use this data. That's the takeaway, but they use it anyways. Taken all together, I think this illustrates that half of their 1 degree warming trend since 1850 is not supported by the data. This makes the climate simulations suspect because after they had to adjust their predictions dramatically downwards, when warming stalled in 2000, their current benchmarks require that the climate warmed by more than 1 degree since 1850, and closer inspection of the data makes it look like the climate only warmed by half of a degree. I'm talking about sea surface temperatures because that's a lot easier to measure than air surface, and they should track one another. So this isn't even the primary reason to be suspicious of the climate simulations. The primary reason is that the simulations have dramatically reduced the sensitivity to carbon dioxide factor over the past decades. This suggests that they are just tuning the sensitivity until the simulation matches the data. This means that their simulations have not demonstrated predictive power. They just have a fudge factor. They don't know how sensitive the climate is to carbon dioxide or human-generated carbon dioxide, which is but a tiny fraction of the total amount of carbon dioxide. The carbon cycle is insanely complicated, and Not only that, the climate simulations have no clear idea of the effect of changes in the Earth's and the Sun's magnetic fields on cloud formation. This level of uncertainty should keep any responsible scientist from making political claims in order to increase their funding. It should also keep oil companies from making claims to protect their industry. But that isn't how science works in the present environment. So in another post I have linked to, I go into hypotheses about how the Earth's and Sun's magnetic fields affect cloud formation. There was a research group at CERN which was trying to directly investigate the impact of cosmic rays on water molecules in a sort of cloud chamber. But I think that misses the actual mechanism. It makes much more sense to think of how the Sun's magnetic field changes the Earth's magnetic field, and this influences the pressure within the Earth, because the magnetic field of the Earth is caused by circulations within the core. And if that changes the pressure and the amount of volcanic activity underneath the oceans. And the oceans are warmed and cooled, well, not cooled, they're warmed by heat from the Earth itself. And changes in this warming would change the amount of water evaporated up into the sky and how many clouds you have in a given year. And you can study this through the El Niño and La Niña phenomenon. It's relatively straightforward. So people who share this perspective include a retired MIT professor of atmospheric science and several Nobel Prize winners in physics, including Freeman Dyson and even a Greenpeace founder. And I have links to videos of their talks in my blog post. The MIT professor of atmospheric science talks about how he's a bit older, and he talks about how his field started out as just a small number of people, and then suddenly there was this influx of funding after a person talked to Congress and said, the sky is falling, the sky is falling. And this influx of money caused people who were not atmospheric scientists to suddenly rebrand themselves and start research groups of their own, which it basically took over the entire field and sent it off in a direction which was frankly not very well grounded in retrospect. And I think right now we can't see it, but in the future it'll become more clear that this is what happens when you give a group of people too much money. They go crazy. Freeman Dyson, he talks about how his early research was in the effect of carbon dioxide on plant growth and trying to make estimates of how plants grow more when there's more carbon dioxide in the air. And the Greenpeace founder is very concerned about how restriction of access to fossil fuels would cause poorer countries to cut down their trees to make charcoal for cooking. I mean, you just have to look at a country like Haiti, where they've cut down all of their trees. And you realize how important it is to be aware of unintended consequences of any of your energy policies. And I'm also very well aware of the burning in Australia. But as I said earlier, the climate historically has changed dramatically due to causes that have nothing to do with people, and we just have to roll with it. We don't have to believe that everything is our fault. I mean, sure, we influence a lot of stuff, but the climate is very powerful compared to us. So the other issue is how easy it is to trick people with pseudoscience, climate pseudoscience. How many kids today know that the tilt of our planet relative to the sun changes in a predictable fashion, and that when one pole gets warmer, the other gets colder? Clearly not enough of them. How many kids today even know what the Chandler wobble is? Or the lunar apse cycle, for example. As a scientist who has spent some time reading climate research, I can only conclude that distrust of corporations and misplaced trust in the scientific establishment is the reason that so many people blindly accept the global warming hypothesis. People see short-term climate changes and they believe climate scientists whose income depends on people believing them when they say that the present-day climate variation is man-made, catastrophic, and in need of more study. In short, the belief results from a form of unintentional, incentivized gaslighting and a tendency for people to want to feel in control of and responsible for something, the climate, which is generally not under our control. The incentives of elites to support a widespread belief in man-made climate change may be related to a realization that fear of the weather could be a powerful tool to motivate a strategic move away from fossil fuels in preparation for the effects of peak oil. I think it is particularly concerning that the dangers of peak oil are projected to occur around the next solar minimum, yet these sorts of real dangers are ignored by the media in favor of carbon dioxide hype. As a person who studied science to try to understand the big picture, seeing such a disconnect between what people are told and what people who really study these issues, the conclusions they would draw, it's really upsetting. There was a lot of popular science press discrediting a professor named Koba, a physicist who ended up on the front page of a few papers for her model of solar cycles and her prediction that we will have a cold spell starting around 2030. But the bad press came primarily from people who had an agenda. Climate change fanatics and people whose solar models disagreed with hers. And I mean, when I say climate change fanatics, I mean the anthropogenic climate change fanatics. First of all, Zarakova is a professor. She collaborates with researchers from other institutes, and she has published her work in peer-reviewed journals. Her publication generated hype because she suggested that we would have a 50-year cold spell similar to the Dalton minimum or the Maunder minimum, times when agriculture was poor and the River Thames froze solid. These time periods were not good, but the human race survived, of course. Her hypothesis is that the sun can be modeled as a two-layer system in which oscillations from those layers combine to form our sunspot cycles. The equation she uses is astoundingly simple, but it fits the data over both long and short timescales very well. Researchers who develop more complicated models are understandably skeptical of her results, since it would mean that their work was not necessary. Her equation is a sum over a bunch of functions with the form a cosine omega t plus phi times cosine of b cosine omega t plus phi. She made a more complicated function by adding a term for a quadrupolar mode as well, and that improved the fit, but of course, adding more ingestible parameters always improves the fit. Zarakova has a talk on YouTube, but she doesn't have typical pop science presentation skills, so it is easy to tune out simply because the style is not terribly commercial. If you skip ahead to around 25 minutes in, you get to the meat of the presentation, and it seems she basically did Fourier analysis of a segment of recent sunspot data and compared that to longer-term and short-term data. She modeled the sun as having two layers with different oscillation frequencies which mix, and it is rather surprising that her fit matches over both 1,000 years and over the past 35 years. It suggests that the oscillations in the sun are quite repeatable, linear, and understandable. Other experts insist that the system is much more complicated and chaotic and nonlinear than that. It might be more complicated, but that doesn't mean that the simple model is wrong. Call it a first-order approximation, but if it has predictive power over 1,000 years and over 35 years, that's pretty darn good. In any case, the model makes a testable prediction. If the sunspots are less frequent over the coming 20 years, she was right. That's how you do science. You make a prediction, you test it. And that's something that I have not seen within the climate scientist community. Their models do not have predictive power because they keep tuning their carbon sensitivity factor. In response to human-caused climate change proponents, Sarah Koba did not claim expertise in the carbon cycle, but she said there is evidence that when the sun's magnetic field is weak, as it is during a solar minimum, the Earth tends to get colder, not because the solar output is so greatly reduced, but because the charged particles from the solar wind influence cloud formation. She correctly points out that the carbon cycle-based climate models do not incorporate the influence of magnetic fields on their models. Not only could solar magnetic fields influence cloud formation, they could influence the frequency of volcanic eruptions. As I tried to explain earlier, and in another link to the dynamics of the core of the Earth and external magnetic fields. Several researchers have done Fourier analysis on volcanic eruption frequency and found that it tracked the 11-year and 80-year cycle of sunspots, sort of cosmic eclipses from some perspectives, or related to the movement of the sun around the barycenter of the solar system. Since we are heading towards a grand minimum around 2050, this could explain increasing volcanic activity. And it may not be the volcanoes you notice that are so important, as in big, dramatic, newsworthy events, but the ones that are underneath the ocean, that heat the ocean and change currents. An older article I found on this topic called Volcanic Eruptions and Solar Activity is quoted in my blog post. It was published in 1989 by Richard B. Struthers, and it presents data that supports this kind of sun-volcano correlation. And I have a couple other links to newer research on that, but I think the older stuff is actually better. Whereas the news media ignores the predictability of global volcanic activity, they will report on the world-ending consequences of an unlikely supervolcano eruption, while also insisting that the polarity of the Earth's magnetic field is mysterious and due to flip upside down, with unknown and possibly catastrophic consequences. What a great headline. Way to terrify everybody over something that's nonsense. I have posted 2 links to what I understand about the Earth's magnetic field and about the sorts of people who are doing research on the idea that it flips upside down. The fear-obsessed media's claims very frequently do not stand up to scrutiny. They like to keep you afraid, and they don't care much about being accurate. After taking a close look at the scientific case, I have been forced to conclude that the fear about global warming is a result of a myopic, histrionic media and young scientists in an overfunded segment of the academic industry who received a narrow, specialized education in simulation tools that have never demonstrated predictive power. As in, they are using pseudoscientific instruments, not unlike a divining rod. I have some pictures of divining rods in my blog post. I'm not sure if there is a cynical, manipulative effort from politicians to support this sort of fear due to an ulterior motive related to peak oil or whatever strategic goals each individual country has, or if they are just caught up in the wave of hype started by Al Gore. I think it's probably a combination of the two. When I was younger, I was dutifully concerned about man-made global warming, and I believed that the scientists knew what they were doing. Then I became a scientist and realized how much nonsense gets called science today. When I took a close look at the papers written by global warming scientists, I was disappointed. I could read them because I was trained in that system, but most people would have a hard time spotting the nonsense. The planet has been warming, but not for the reasons that the media claims. In contrast to the simulation tools which can be used to manufacture any outcome, history suggests that we are due for a cooling trend, not a planet-destroying, out-of-control feedback cascade of overheated chaos. And the current chaos that we have very likely could have been predicted with such simulation tools, but it wouldn't necessarily have been driven by human-produced carbon. I don't know how good the simulation tools are, honestly. I only know that in accelerator physics, it is extremely easy to simulate whatever you want, because there are so many situations that are sensitive to small changes in input parameters. And if the climate works in a similar way, which it does, you have to be very careful about how you use simulation tools. So most people would read this article or listen to this video and ask themselves, if you're so smart, then why aren't you a billionaire? Well, I'm not that smart. I just quit my job to spend more time with my kids, and I have had some time to think in peace and quiet while the kids grow up. And even if I could predict the weather, I would still have a hard time predicting the direction of the economy, since central banks try to compensate for changes in the weather. This means that I don't know much about the short term, but there are still some interesting historical charts that make me wonder if we can make long-term predictions. Since politics is influenced by the economic climate, and the economic climate is influenced by the global climate, and the global climate is influenced by the cyclical natural forces that could lead to some predictability in long-term trends. There are Milankovitch cycles driven by the orbital relationship of the Earth and the Sun. There are solar cycle sunspot changes driven by the magnetic field of the Sun. And there are El Niño cycles, which may be driven by volcanic activity underneath the South Pacific. In a non-ironic twist, economic theorists call extrinsic variables that are hard to quantify sunspots. El Niño is particularly interesting since it cycles frequently enough that you can get more statistics on it. And I have some links to that. Back when we had a purely agrarian society, it was easy to see long-term trends linking the economy, politics, and the agricultural climate. Today, it is not clear to me if the economy has fully decoupled from this climate oscillation or if we are still driven by it. If we are fully decoupled, as in modern monetary theory, then past trends will have no predictive power. But if we are still coupled, as in the Kondratiev wave of Austrian school economics, or theories of decline after reaching peak oil, then history could provide some guidance. But in the short term, it all comes down to politics, because people buy, for example, gold when they don't trust the government to manage their money supply. But when I understand my limitations, I know this is uninformed speculation of a non-expert, and I have no record of predicting such things. And there are so many factors out of our control that making predictions is a bit foolhardy, especially in the short term. I've learned that I tend to panic about things far too early, and being right too early is about the same thing as being wrong. The truth is that I don't have enough experience to have any intuition in this matter. I can only read the numbers in charts and go by that, and even then, I don't know all of the variables that come into play. What I can see is that during the last 2 stock market crashes in the US, the gold price didn't get a big upswing until the US stock market was already way down. But in real inflation-adjusted terms, the peak price happened before the upswing. The other thing I see is that either we haven't bottomed out yet on the Dow-gold ratio, or we may not be due for another major gold buying panic, as in 2000 through 2012, for another few decades. In conclusion, about how to use these sorts of the sort of analysis I can do to make real predictions, I have many ideas, but really I have no idea. Even using our best scientific methods, there are still things we cannot predict. Yet a new crop of computer scientists has sprung up, claiming that they can predict the unpredictable. If these sorts of computer scientists or data scientists succeeded in getting everyone to abandon the classical scientific method and adopt their version of what qualifies as science, a sort of prediction without a benchmark, analytic models that anyone can use would disappear and be replaced by supercomputer-based simulation models that overfit old data and have so many input variables that they can predict whatever the user wants them to predict. This would take the power of basic science out of our hands and sequester it in the hands of wizards at, for example, military labs like Lawrence Livermore National Lab. If I'm being paranoid, I think I don't want to give up the scientific method in exchange for AI data miner fortune telling everyone that the story that they want to hear. If you construct models that have not demonstrated predictive power with statistical significance, and you do not warn people that your model is unscientific and unverified, then you are not a scientist. And I think that many climate scientists have committed this crime. If you encourage people to take action based on such a model, you are as irresponsible as those physicists who warned all of us about a human population explosion and catastrophic collapse that should have happened 20 years ago but didn't. What if an idiot billionaire had taken that projection seriously and engineered a preventative plague in response? What if an idiot billionaire takes the climate projections about the future produced by people at Lawrence Livermore National Lab, and they decide to fill the upper atmosphere with sulfur and particulates, thereby causing a famine that kills billions? I think students today need to understand how wrong and dangerous unscientific methods can be. The scientific method is the only way we know of avoiding delusion, and if you do any of the following and call it science, you are dangerously deluded. Let's see, we've got data dredging, searching for random correlations and inferring causation and statistical significance where there is none. P-hacking, repeating your measurement until you get the result you want and then claiming that the result is statistically significant when it isn't. And then the one that happens very frequently today is non-falsifiability, fine-tuning an overfitted model until it matches the measurement, and then claiming predictive power. Real scientists know that these are cardinal sins. Just imagine if those methods were used to search for people suspected of wrongdoing and to gather evidence to prove their guilt in a sort of pre-crime minority report scenario, which, according to articles in the news media, it's already taking place, and there are perfectly innocent people who find themselves under the microscope for almost random reasons. What can you do? So I have a quote from a data scientist at Lawrence Livermore. He says, "Scientists are much more likely to talk about models than hypotheses or theories." Quoting E.P. Box, "All models are wrong, but some are useful. Because we are focused on utility instead of correctness, we can get a lot more done without worrying if a hypothesis is right or proven or correct. Simulation has upended how we think about science. The ability to take a handful of models and scale them up to run on supercomputers has opened up worlds in chemistry, physics, biology, astronomy, and engineering that we couldn't dream about before." Has it opened up science fiction worlds? Sorry, that's my commentary. Of course, the individual models were wrong, and wrongness can accumulate as you run a few million models a few million times a second, but in a lot of fields, that is how science is done. And he writes, and done successfully. So the fact that scientists are achieving popular success with unscientific methodology should concern everyone, because these people are getting the stamp of legitimacy and making powerful predictions, which are not produced using, I guess, what you'd call best practices. So what this scientist from Lawrence Livermore has described is a situation in which a model cannot be falsified. Instead, the model lasts for as long as people believe in it. And that is religion, not science. Falsifiability is the cornerstone of the scientific method. Without it, you end up calling string theory science instead of philosophy. You also end up simulating pictures of the universe or of distant astronomical objects and calling that science. It isn't. It's art. You could start out with the hypothesis, person X has a criminal temperament, and keep digging through ancient data until you find evidence to support that claim, even though they've never committed a crime. The only valid scientific method is to make a prediction and then measure that predicted thing happening over and over until you are sure that it is repeatable. This is what I learned by working with a machine in experimental physics. If a computer scientist tells you otherwise, he is not a scientist. He is drunk on the power he imagines his simulation tools have given him. There's an additional problem in that prior to about 1960, the data we had was human collected, more or less manually, but now we have instruments that can generate petabytes of data over a long weekend, and people are still figuring out how to make best use of those fire hoses. They are very problematic because with enough random data, if that data is noisy, you can find whatever result you want to. With infinite random data, you could find the complete works of Shakespeare. And nowadays, bad scientists are using templates of the signal that they want to find and then searching for it within petabytes of noise. This is very bad, and yet no one seems to notice because they have forgotten the importance of the scientific method. So I think I've run out of steam. This was really long. I thank you for watching, and I encourage you to take a look at the blog post because there are a lot of links to supporting material there. The next post won't be so long. Thank you for watching.